my take on the Wolf Prize in Chemistry, Frank Albert Cotton, 2000. You got 1 out of 1. I'm filming this over 20 years later. Monday, 9 September 2024. I'm Tanis Coralee Leonhardi, she, her, hers of Seattle, and I'm talking through the Frank Albert Cotton, he, him, his of the United States of America, Wolf Prize in Chemistry, Year of Award 2000. He won the Wolf Prize in Chemistry, 1 out of 1 of the prize, 100%, for his research regarding the nature and characterization of metal-metal bonds, including singular and plural, more than one, bond /atom. I provide my take / perspective on his award and contextualize it in terms of the legacy of his research, in terms of the significance of the research outside of chemistry, such as geology. Yeah, this is like science. This is like how prolific this work is. You know, like, so essentially, if you've got transitional metals, you got a periodic table of elements, if you know what that is, and like they're different chemicals, like chemical elements, and if they're metals, you know, there's like one atom and another atom, and sometimes there's a whole like group of atoms, how they interact with each other, the bond, yeah, is different. And so essentially, but you know, before people go and characterize that, you couldn't guess that, but that doesn't mean you know that, much less can quantify it or describe it concretely with evidence, right? So that's what he did, was like essentially like that thing that we think is possible, can we actually prove that it like exists, right? Like, or provide evidence that it exists. So he did, and he characterized metal bonds, and it's very so in terms of collegiate degrees and minors, I'm geology, geophysics, and mathematics. Degree, well, yeah, that's okay. And so this is one that I did. I have like passion projects and stuff, and metal bond chemistry, I would say, is really cool when combined with physics and geological contexts. And so that was, as an undergraduate, I did a couple of theses, and we went on to publish both as part of like we expanded beyond what I did for my theses and published both. But for both projects, we looked at the chemistry, and one of the things that I think is really, really cool in geological context and geology is those bonds that, like in chemistry, it's just like, okay, they want a certain interaction, or they want whatever they want. Or in physics, they want whatever they want, either super big or super tiny. And in geology, we're like, did you know that being titanium and iron versus iron and iron can actually result, and that nature of that bond can actually result in a different mineral structure. Whoa! Or the nature of that bond means that certain chemical elements might be present in certain minerals more than other chemical elements because of the nature of those interactions. Whoa! And did you know that those chemical elements come from fluids in the rocks or in the magma or gases? And so essentially these different chemical elements that get brought in, we can take and see through these different interacting metal atoms and other combinations. What the heck happened? How did that little mineral in that piece of obsidian get there? What were the processes that worked inside that volcano? Okay, so it's so cool to take and be able to like, so yeah, there's the like really super stripped down chemistry and physics, right? It's not the messy nature stuff, but I've worked on the messy nature stuff, and it's so cool to be able to actually figure out and find evidence for the processes that have happened based on these really simple physical and chemical definitions and characterizations. It's so cool. Yeah. So this is really freaking cool, and it is really freaking cool applied in, this is what a lot of people get wrong. So geology, geo means earth, ology, study of the earth. I, within that, work on rocks and minerals. So, okay, minerals, mineralogy, rocks, petrology. Okay, so it's really cool when applied in petrology, study of rocks. So geology is not the study of rocks. That's technically wrong. That's one of those stereotypes a lot of people get wrong. So I'm just correcting that. But this is like It's like food, right? You just like read it, and you're like, and then I look at my thin sections, and I look at the hand samples, and I go, it's so cool. So that's how I feel about this one. Is this the greatest of all time? No better solitary performance in any arena in 2000? Possibly. At least from me, right? This is my take. The Wolf Prize in Chemistry, Frank Albert Cotton, 2000, 1 out of 1. Filming this again, Monday, 9 September 2024. And I'm this little weirdo, Tanis Coralee Leonhardi, she, her, hers, us, yo.